Hello and welcome back to distance signal processing. In this video, I'll explain about convolution. Convolution is the mathematical way of combining two signals to form a third signal. As you all know, there are two types of convolutions, linear and circular. In linear convolution, we calculate the output of any linear time invariant system given input and impulse response. Here, the samples and output can be of different sizes. In circular convolution, input, impulse, and output sequences must be of same size. So for this, we go for zero padding. That is, adding zeros at the end of the sequence. And to perform circular convolution, we use mathematical matrix multiplication. So let us start the two methods of convolution, linear and circular. First, I'll explain about linear convolution. So let us take two samples, x of n. Let us suppose 3, 4, 1 is a sequence. And y of n be 2, 3, 4. As I told you, the sequences can be of different sizes. And to calculate linear convolution, this process is same as the correlation in distance signal processing. So x of n is one sequence and y of n is the other sequence. The output sequence consists of how many number of samples that we can calculate. So x of n consists of 4 samples, 1, 2, 3, and 4, plus y of n consists of 3. So 4 plus 3 minus 1 will be the number of samples in the output sequence, that is 6. Now we'll calculate the linear convolution. So the process is same as the correlation. That is, take the values of x of n horizontally and take the values of y of n vertically. So 2, 3, 4, and 1. This is x of n. And 2, 3, 4. This is y of n. Next, what we have to do is multiply first element of y of n with all elements of x of n and repeat the procedure with all other elements of y of n. So let us start. 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 1s are 2. 3 2s are 6, 3 3s are 9, 3 2s are 12, 3 1s are 3, and 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 3s are 4. So once the procedure is completed, then what we have to do? We have to perform addition diagonally to get the output. So 6, 8 plus 9 plus 8, 12 plus 12 plus 2, 16 plus 3, 4. So the output sequence will answer. So let us suppose it is z of n is equal to 4, 6 plus 6, 12, 8 plus 9 plus 8, 25. 12 plus 12 plus 2, 26. 16 plus 3, 19. 4. So how many elements are there? 1, 2, 3, 4, 5, 6. So this is this in x of n, the number of elements in x of n and number of elements in y of n. So 4 plus 3 minus 1, so 6. So we've got 6 elements in set of n. So this is how we can perform linear convolution. Now I'll show you how to write the Matlab code for the linear convolution. Now we'll start writing the Matlab code. first for the linear convolution. So take the sequence. X is equal to 2, 3, 4, and 1. And y is equal to now we have a function called convolution CONV. So z is equal to convolution of x, y. So this is how we have to perform. Now we can plot. So subplot of take one semicolon stem of x, and then we give labels. Y label as amplitude of x, semicolon. Next, x label as time, similarly we'll plot y and as well as the z. So this will be the second plot, this will be your third plot, this will be your y. So we are plotting input as well as the output set. Now save your file. You can save your file, you can do something. Save. Drag. So this is x, y. Sorry, we have to change the number, plot number 3, and then change this as y because amplitude of y and amplitude of z. Right? And here you can see the values here. You can see the values here. Right? See, we got the same values that we measured manually: 4, 12, 25, 26, 9, and 4. Now run the program. So this is these are the values that we have given of x. These are the values of y and the values of z. Values that we got. You can see here clearly what are the values we got here. So this is 4, and then you have 12, and then 25, and then here you have 26, and 18, and then 4. So this is how we can measure linear convolution. Now let us go for the circular convolution. Now let us go with the circular convolution. So I told you in the circular convolution, all the sequences must be of same size, and we will use matrix multiplication. So we'll take same example, x of n as 1 and y of n as 2 and 4. Now we have to use matrix multiplication. That means you have to represent x of n and y of n in the matrix form. Before that, we have to check the size. As I told you, the sequences and output must be of the same size. So we know x of n size is 4 because there are 4 elements. Y of n is 3 and output is 4 plus 3 minus 1, that is 6. So the x of n, y of n also must be of size 6. So for that we go for zero padding. That is, we add zeros at the end of the sequence and then we'll write in the matrix form. So x of n, it requires two zeros, 2, 4, 1, 0. Whereas y of n requires 3 zeros, right? So we can write it as 2, 0, 0, 0. Now we'll perform matrix multiplication. For that, we have to construct the matrix. So first we'll take x of n, right? So what is the sequence? 2, 3, 4, 1, 0, 0. So 2, 3, 4, 1, 0, 0. Now, the next row is so we'll circularly rotating the elements of x of n. So first put the 0 here. Next 2, 3, 4, 1, 0. Now you bring the next 0 also to here. So this 0 will be moved down. 0, 0, 2, 3, 4, 1. Next 1, 0, 0, 2, 3, 4. Next 4, 1, 0, 0, 2, 3. Next 3, 4, 1, 0, 0. Next. So next is the 2. Again, the same sequence continues. So we have to stop here. So this is how we have to circularly rotate the elements of x of n to write the matrix. And y for y of n, which you take as it is 2, 3, 4, 0, 0, 0. And then perform the multiplication. So row into column, we can write it as here. So 2 2s are 4, and these 2 are zeros, and other are zeros. So we get only 4. Next, 3 2s are 6, plus 2 3s are 6, plus this is 0, 0, and 1 into 0, 4 into 0. So we get only 12. Next, 4 2s are 8, plus 3 3s are 9, plus 2 4s are 8, plus all others are 0. So multiply, you'll get 0. Next, 2 1s are 2, right? 4 3s are 12, 3 4s are 12, and others are 0. So next, this is 0, 3, Next is 4, 0, 3, 4 fours are 16, right? And the other one is 0, 0, and 0. Next, 0, 0, only 4 we get. So these are the elements we get. So what are the elements we get? This is equal to 4, 12, 25, 26, 19, and 4. If you see here in the linear convolution also, we got the same sequence, right? So now let us write the program for the circular convolution. So I hope you understood the difference between the linear and circular convolution. In the linear convolution, we'll construct we'll take the values of x of n horizontally, y of n vertically, and then multiply each element of y of n with all the elements of x of n and repeat the procedure for the other elements of y of n, and finally perform addition diagonally to get the output. And in case of linear convolution, the size of x of n, y of n, and the output can be of different sizes. Coming to the circular convolution, so first we have to make the size equal. So for that we go for the zero padding, that is add the number of zeros at the end of the sequence. So x of n is 4 size, y of n size is 3. So the output size is 4 plus 3 minus 1, 6. So we have to make x of n, y of n also of same size, 6. So here there are 4. So add 2 zeros at the end. And in y of n, there are 3 elements. Add 3 zeros at the end. So that x of n, y of n, and the output set of n will be of the same size. Once your zero padding is done, write the matrix. And how to write the matrix of x of n? First, take the elements as it is, then start circulating the elements, right? So 0, 2, 3, 4, and 0, next 0, 0, 2, 3, 4, until we get to the, again the first column will be repeated, right? And then take a y of n as it is and then perform matrix multiplication. We get the same elements here, you can see the same values. That is called circular convolution. Now I'll show you how to write a Matlab program. Now I'll show you how to write the program for the circular convolution. So the first thing is we have to go for zero padding. So x pad is equal to x comma. We have to write zeros of how many zeros we have to add, starting with 1 comma 6 minus length of x, right? Similarly, so it will start with 1 and 6 minus length of x, 6 minus 4, 2. So 1, 2, 2 zeros in there. Y pad is equal to y comma zeros of 1 comma 6 minus length of y, right? So zeros of, so starting with 1, 6 minus length of y. Length of y is 3, 6 minus 3, 3. So 3 zeros, 1, 2, 3. 3 zeros will be there. Now, to find the circular convolution, we have to use inverse Fourier transform of FFT of x pad, right? X pad into, that is star dot star, that is array multiplication, that is each element must be multiplied, right? Y pad. close this and put the semicolon. So that is the Y pad. Now we can save the file. So say we can file, or we can give a new name. Save as. We'll write circular. Save. Then run the program. Let us see the output of this. So see here, this is X values what we have taken, and Y values, and the Z values what we got for Y. This is Y, and then 19, 4. So you can also see the values here. So these are the values. This is the padding. See how many number of zeros we have added in the program. 3 added, and for X2. So this is about the circular convolution. I hope you all understood what is the linear and circular convolution. So convolution is basically the way of combining signals to form a third signal. We have two types of convolution, linear and circular convolution. And linear convolution is similar how we perform the correlation. So this is a process of say by taking the values of x of n horizontally and phi of n vertically, and then multiplying the first element of phi of n with all elements of x of n, and repeating the procedure with all other elements of phi of n, and finally performing the addition diagonally to get the output. And coming to the circular convolution, first we have to make the sizes equal by using zero padding. So make the size of x and y equal with the help of zero padding. Add number of zeros and make them equal. After that, we have to find the circular. Manually, just we use the matrix multiplication, and the matrix multiplication we just rotate the values of circularly rotate the values of x of n and form a matrix and multiply with the elements of phi of n to get the output. And here in the program we use IFFT and FFT of x pad into FFT of y pad, and then find the inverse last Fourier transform to get the circular convolution. Hope you all understood.